February 6th is the schedule. We'll check in on. All right, ladies and gentlemen, I'd like to call this meeting of the Delaware Astronomical Society for January 2026 to order. First thing, do we have any new members who'd like to introduce yourself? Anybody? I don't think there's any new members that I see. All right, great. Anybody who's just visiting that's interested in joining or interested in learning more? Nope. Okay, great. Next thing we have dues. Bob, I'll turn this to you.
We're still in the process of collecting dues for 2026. We have about 140 people that have renewed, and thank you everyone who's renewed. It makes the club keeps the club going. So thank you. We still have a few more people that would like to have sign up, and you should have gotten an email from me last night. There's 4 or 5 different ways of paying. You can pay through PayPal a couple different ways. You can mail a check to me, or give it to anybody, any officers here during any of the Tuesday meetings, either the main meetings or any of the workshops, whatever. So there's still a chance to pay your dues for 26. But thank you everyone who has.
Very good. Next thing, we got outreach events. Jim, you want to say something about that?
Yes, I have a couple of outreach events I'd like to speak about. We had an outreach event January 3rd at Lum's Pond, but that got clouded out. So we rescheduled it for this Friday, January 23rd from 6 to 8 p.m. It's looking pretty iffy for that event also. But anyway, all those folks that have responded positively to be at the outreach event at Lum's Pond, I'll keep everybody informed to see, well, when it becomes clearer, when it becomes more apparent what the weather is going to be. For the second thing, we have another event coming up that's sponsored by the Newark Parks and Recreation Department. It's entitled Cocoa and Constellations, and it's going to be held on Friday, February the 6th at the Newark Reservoir from 6 to 8 p.m. So please mark that on your calendars too. And that's all that we have for upcoming outreach events. The one this Friday at Lum's Pond, and the one on Friday, February the 6th at the Newark Reservoir. And I think Greg Lee maybe has a couple of outreach events that he wants to talk about also.
Yep. Yeah, one later on in February. It's that time of year again when the Wilmington Friends School has the 7th grade astronomy unit. So for 30 years, we've been taking out telescopes. Their 7th grade class is large enough that we schedule it for 2 nights. They split up the size of the class. And this year it's going to be on Monday and Tuesday, February 23rd and 24th. It's a short 1 hour, 7:30 to 8:30 event. But these kids are really the good ones. They ask the good questions. They know a lot of stuff. They're a lot of fun to get out and talk to. That's the end of the month, February 23rd and 24th. I asked for volunteers for both nights or either. So if you can do one or the other, if you can do 2, that's great. History has shown us that one of those nights will get clouded out anyway. So
sign up for that one.
So yeah.
What time is that again?
It's 7:30 to 8:30. I will put out another notice with my contact information on it, and if you just let me know if you can help out one or.
Have you messaged that one yet?
Those nights.
Have you sent
Nope,
Oh, okay, you said another message, that's what threw me.
I have not sent out one for this.
Okay.
This event yet, but I will do that this week. And, anyone who volunteers, I'll send you the details.
Someone walked in and then went that way.
How to
Oh,
get there.
went the wrong
It's
way.
in a private home of one of the Friends School, family members,
Is that the same place as last year?
same as last year.
Okay. Are we gonna see the exhaust from a rocket again like we did?
I don't know. On schedule, what
You got that scheduled, right?
Yeah.
Okay. Or.
The expectation
maybe,
is what's that?
Aurora.
Yeah, right.
Yeah.
But, yeah, okay, that's for now.
Thanks, sir. Wonderful. Next thing, we have is the AP Sig. You want to say?
Yes, the next meeting of the astrophotography special interest group is going to be January 31st, Saturday. And almost certainly on Zoom, since it's been pretty cold and snowy. I don't think we'll have any volunteers that are that much. So, and be sure and pay attention to das@groups.io for the announcement.
Thank you very much.
And actually, a key segue, for any member who is not on the groups.io, it's, I would say, highly recommended to get on there. It's how we kind of stay in touch with each other in between meetings. If anyone does not know how to do that, number one, look at the website. Number two, come talk to Rob or I after the meeting. We'll get you set up. It's very simple.
Yeah, absolutely true. Next thing we have is the book club. Mary, you want to tell us about that?
Yes, good evening, everyone. The book club will be meeting via Zoom next Thursday, January the 29th at 7 p.m. And we will be discussing Vector, a surprising story of space, time, and mathematical transformation by Professor Dr. Robin Arianrod. She's a PhD in mathematics. Her dissertation was on the mathematics of Einstein. And her book treats the history of the mathematics needed to achieve what we now call astrophysics and theoretical mathematics. She takes you from the mathematics of the static and she moves you through to what's needed for movement and dynamism. So it's a fascinating book. And in February on the 26th, as part of the honoring of the Artemis mission, we are meeting to discuss Moon Garden, a guide to creating an evening oasis by a gardener from New York, Jarima Osofsky. And we'll also be joined by the very eminent Leanne Heinian, who wrote Night Magic, Adventures Among Glowworms, Moon Gardens, and Other Marvels of the Dark. The director of the Edison and Ford Winter Estates in Florida will be joining us to discuss their moon garden, and the meeting will be led by Diane Turnchek, who was featured in the New York Times this past year for her work in dark sky conservation. We have the Delaware Federation of Garden Clubs who will be joining us, and they number up to 650 on their list. So we're very excited about that. So thank you.
Thank you very much. Wonderful. Do we have any other announcements? Because that's always on my list.
Calendars and books.
Oh, right. I knew I forgot something. Thank you.
Okay, I have, for those who have picked up their calendars and books, I have them. And please contact me if you want to do that. What I think I'm gonna do is I will bring them to the next meeting. And those who have not paid for them, whoever is there that wants them will be able to get one. So at least by next meeting, I'd like to. Those with the handbooks, they already have names attached and they already paid, so we're good. Okay, and Jim Kirchen, I have your handbook. And I can drop it off and leave it in the library or with your name on it, or just email me how we can get it to you.
Good. Very good. Any other announcements? All right, I think that's it.
Cool.
Jeff, let's carry on.
Well, we have a bit of a theme tonight. Rather special speaker. To set it off the theme, I'd like to start by acknowledging that today is the birthday of Buzz Aldrin.
Oh, right.
So I thought it would be very timely to have as a very, very special guest speaker tonight. Sorry, not Buzz Aldrin. I hate to set it up that way because there's no one in this room. We are doing member mini talks today. Wouldn't that be amazing if Buzz Aldrin walked out of the?
Well, Mary Webber would probably get it.
That's true. Yeah, exactly.
Mary can do it.
Buzz is 92 or 96.
Wow.
Yeah.
But most importantly, still alive.
Yeah, exactly. Yeah. So anyhow, very cool. So yeah, member mini talks today. Lynn, would you like to kick us off?
Want to kick us off? How about if you, I'll let you open up the images.
Yeah. You got it. You want me to operate the computer for you?
Yeah.
Okay.
Okay, some of you, there's
Hang on, let
a
me-
few guys here
Jeff, you want to share the screen?
Yeah, I'm working on it.
that,
Give us 1 second, Lynn.
okay,
Yeah, because they won't see anything on Zoom if you don't share the screen.
all right.
That's the show.
And then last thing is we will, nope.
Pin yourself first,
Yeah. Let's get that order wrong.
then do that.
Nope, didn't work. Oh, no, now I have to do this.
Yes.
And then I do, any order to these, Lynn?
No, let's just open them up.
See what we get. Can folks online see this photo?
Yes.
All right, go for it.
Okay. You guys, who have been here a long time, there's a few people here. Remember my son Wayne?
Absolutely.
Ah, and he basically started astrophotography out here when he was in college, and the first picture he took was the Orion Nebula. And these are his most recent pictures. What we're seeing up here is the Elephant Trunk Nebula. These are his most recent ones. Okay. I can remember some of these. That one is unusual.
Okay, cool.
Yeah.
Where were these taken?
He lives in Croydon. And which is near it's near the, it's 2 miles off the exit when you go up I-95 to Parks. You get off at Parks Casino exit.
Yeah.
He's 2 miles from there.
Yeah, I thought he lived like in Philly or
Yeah,
near.
it's in North Philly, and he's
Okay.
just 5 minutes out of Bristol.
These are from his property?
It's from his backyard.
Okay.
Yeah.
So did you use a filter to get the colors or what?
He filters them. I don't know if I can see what's down at the bottom. It's hard to read
Yeah.
what's written there.
I think it says sulfur 41 times 120 seconds. And then hydrogen alpha 43 times 120 seconds. And then O3 43 times 120 seconds.
Yep.
That's cool.
Is that right?
Yeah.
Yeah. Okay. I think that's what it said.
Okay,
And let me know, you want to advance?
and go to the next one. There's your bubble or the dumbbell.
Mhm.
That is a dumbbell. And he took, he's taken that several times, but he gets better cameras and he pulls around filters.
And it's also in sulfur hydrogen alpha 1,3.
Mhm.
Yeah, if you can read what's down there, I can't.
Yes.
Okay, next one, that's 4.
Oh.
That is,
That looks like
It's the crescent.
what does it say, the crescent?
NGC 6888.
Yeah, that's the
The
crescent.
crescent has that
Crescent
star,
nebula.
that bright star up there.
I don't remember.
But remember, it's a narrow band, so it might.
Oh, you might not see the star.
Yeah, the star would be different.
Because of big oxygen bubble.
Crescent.
Is this a supernova?
It's the present, yeah.
It's the crescent.
NGC 688.
Yep.
NGC 6. Triple
Yep.
Crescent. Find out what the color is.
Looks like same filter setup.
Okay.
Cool. Next.
Mhm. There's your bubble.
That's nice. A lot more detail than you see without the filters.
Cool.
Very cool.
Okay. And one more.
Back to the beginning.
There should be one more.
2,
That's it.
3, 4.
That's it, 4, that's it.
Were you expecting 5? Uh-oh.
There's only 4 in the thing.
4.
1,
1.
2, 3,
yeah.
4. What do we see? Oh. Wait a minute. 1, 2, 3, 4. Oh, we're missing one. 1, 2, 3, 4, 5. We're missing one.
Uh-oh.
Uh-oh.
Next time.
Yeah.
I'll bring, okay, I'll make sure we get, the other one that he did was the Rosette. And if you've seen the picture of this month in the calendar,
Oh, okay.
it's not his picture.
Yeah.
But I will make sure that I bring that one for next time. I thought
I grabbed everything out of the folder, so I
I
don't know.
when I copied it.
Yeah.
Cause I know what was in there. I'll go check it, cause that's a copy
Okay.
of what I have,
Cool.
so.
Be sure to tell Wayne those are beautiful.
Yeah.
I will do it.
Yeah, thank you for sharing.
Well, I will tell you, if you see what you see from the calendar,
Mm-hmm.
that I asked him, I said, is that yours?
Mm-hmm.
He goes, no. I went, okay, I'll make sure that the Rosette comes next time.
We'll wait on the edge of our seat for next.
Yeah.
Huh?
We'll wait on the edge of our seat for next time.
Okay,
Thanks, Larry.
Okay.
Good?
Yep.
You ready? Okay, Rob.
Sure.
I got it here somewhere. We don't need this anymore. And somehow slideshow, is that it? Rob's gonna be talking about a new toy that he bought.
Change things a little bit. Did everyone see that online? Hope so. Didn't hear anything. Hope they did. All right, well, I'm going to tell you about my new astrophotography camera. And I have a kind of a hands-on demonstration here I can show you. I'm not going to pass it around or anything. I'll hold it up for you. So you want to come up and see it. All right, so the first thing is, why would I want to get a new camera? Because I have a cool astrophotography camera and it takes pretty good pictures. So why would I want another one? Well, because number one, the new one is going to have less noise, significantly less noise. It'll have much greater sensitivity. It'll have much shorter exposure times. Because with my current S-Big, the shortest I could really do is 1 second. And I know it says it can do 0.1 seconds, but that mechanical shutter makes anything under a second just useless because it gets messed up by the shutter and it's not good. But the new camera can do images as short as 32 microseconds. So it can do video, basically, or better than video. It can do high-speed video with it. So that's pretty cool. It also has a significantly bigger sensor and more pixels. So I can get much bigger scenes in the same telescope. So that could be cool too. Here I have the quantum efficiency curve so you can see how much more sensitive it is. The maximum sensitivity of the S-Big was close to 60 quantum efficiency, 60%. But this new one gets up to 91%. So that's a lot better. Now, if you look at any given wavelength, it's not necessarily going to be 2 or 3 times more photons coming in and getting recorded. But, it does have a peak quantum efficiency that is greater. And if you look along the curve, even at the ones that it's not that much greater, it's still greater. So you get more sensitivity at most every wavelength. Because what I was saying is if you look right over in here, like up here close to 1,000, they're about the same, right? And when you get up to the ones that matter, the visible light stuff, then it's significantly higher on the new camera, and particularly in the blues and greens, which the human eye is great at seeing. So for 03, it would be fantastic, right? Fantastic. So there's numerous reasons to get a new one. Camera technology has come a long way in the last decade or so. So definitely worth getting it.
And you're the 13-year-old SB you purchased used,
Yes,
so it's even older than that, right?
that is true.
Yeah.
So I bought the S-Big in 2013, and I think it was a model from 2009. So, I mean, it's more than 15-year-old technology. That is true. Does make it much older in effect. In terms of the noise, we're not just talking a little bit less noise, it's a lot less noise. The dark current essentially becomes insignificant. The read noise is maybe 1/9 as much sometimes, or maybe 1/3 if it's a little worse in certain spots. So it depends on exactly how bad, but it's much better. At times they've managed to find error combining the read noise and dark currents of just 15 electrons in a 15-minute exposure. So that means it's pretty much insignificant. Some people say you don't even need to take darks with this camera. I'm still going to take darks because it's so easy to do, but that's pretty cool. This is my Christmas present from my lovely wife. She said, "What would you like for Christmas?" And I said, "Well, I kind of would like this." And she said, "Okay." So there you go. It's a ZWO ASI 2600 mm, and it has a EFW filter wheel. Here is the camera, holding it up for you to see. It has on it the same stuff that I had on my old camera. So it's got the same paracord that I had on my old one, some of the same adapter rings and extension tubes. And actually inside the filter wheel, I have the same exact filters that I used on my old S-Big. That was one of the things that I kept in mind when I was getting a new one. Is my old stuff going to work with the new one?
So new filter wheel, but old filters.
That's correct. Exactly. And that actually is where most money is in the filters. They're expensive filters. So being able to keep the filters is a critical thing. So I received that on Christmas, and then I was playing around with it, testing it out, taking darks. Couldn't really take, pictures through my telescope yet because I hadn't transferred any filters, hadn't put it all together yet. So I was just running little tests on it to see how it was working. And the darks did look quite beautiful because, I had seen plenty of darks with my old camera. So I saw the ones with this one. I was like, that's really cool. So I was very excited about that. And of course, I tested out, how does it work in terms of cooling? Is it working well? So I tested everything out. And then I played around with some of the adapters and stuff like that. Then after I got back, because we were visiting relatives over the holidays, after I got back, I transferred those filters. And I had to do it very, very carefully. This was like a surgical environment. I set up 2 air filters on the sides of my workbench, and I left them running for like 3 hours before I even started. And I laid out a bunch of paper towels on top of the workbench, to keep the dust away and any dust and grime and stuff like that. I got some gloves to handle the stuff, and I got one of those little bubbles, those little photography dust blowers to blow the dust off them, because you don't want to use something like an air can because those will have propellant coming out along with it. You also don't want to use something like a compression tank or an air blower or anything like that, because that can have stuff inside of the tank as well. So definitely not a good idea to use those things.
Leaf
A
blower.
little dust, yeah, definitely not a leaf blower. So, but it is very important to try and keep the dust to a minimum. You want to try and prevent the dust because you'll have all these donuts in your images that you then got to deal with. And I've had issues with those over the years, so I wanted to get as little dust as possible. What I didn't do was clean all the filters, because that's a whole other set of preparations and it's a whole other complicated thing. So I'll only clean them if I really have to. And they looked fairly clean. And as you'll see, the photographs look like they don't have any dust. So we're pretty good. So I'm crossing my fingers I don't have to clean them. Then I did my first exposure after I got done transferring everything. I took the moon because there were clouds in the sky, and that's all I could see was the moon. And it was through a layer of clouds. So, the clouds were coming by, it was kind of haze. Couldn't see it too well with your eye, but the camera could sure see it through the clouds. And this is a 0.01 second exposure. It's a single exposure of the moon through the clouds. Then to test its sensitivity, I found a cleared patch when the clouds move out of the way. And I took a picture of the Orion Nebula. And this is a single 1 second L exposure. There is a full moon, and that's what came out in 1 second.
And that's before calibration.
I didn't do anything. I didn't do any calibration, no dark traction or removal or any of that kind of stuff. One single frame, raw, I just auto stretched it.
What's the L exposure?
It means it doesn't have like a red or a green or a blue. It's a clear filter. The only thing it's blocking is maybe ultraviolet and IR. Okay. Then I decided it was time to get my spacing right, because if you don't know, you've got to make sure that the spacing between the paracord and the camera is correct so that you get nice round stars. If they are not correct, then you're going to get little comets at the edges of your image. The stars are not going to be perfectly circular at the middle of your image. So I did a whole bunch of calculations actually before we got the camera. And I did all these predictions in a spreadsheet. And I said, okay, I'll need this and this and this. I already have this adapter. I already have this. I added it all up, got 55. I actually did it 2 different ways. I said, okay, I could connect it this way. I could connect it that way. I'll get to 55. I'll be good, right? No. I took the picture, looked at the corners, and no, they were not pinpoint stars. No good. So then I started playing around. I had bought a new adapter to make this work with the new camera. And I had the old ones from my old camera. And so I just started playing around with lengths. I did a study. I tried 48 millimeters, 55 millimeters, 57 millimeters, 60 millimeters, 66.5, and 76. I just stacked together the filters however I could come up with to try and get those stars to be pinpoint. And I found somewhere around here, it worked pretty good. So this is at the one extreme, around 48. This is the other extreme, around 76. This one up here, second from the top, that's actually what it was at 55. So that's what alerted me that this is not right. So I played around with it a little bit, and I'm pretty sure somewhere between 58 and 62 is the sweet spot. And I actually can play around a little bit more with that. I'm not convinced I've got it exact, but they are pretty good right now. Because I did buy a 12.7 millimeter adapter to add to my other adapters. And I decided when I combine these, I get to 58. And if I swap for one of my old adapters, I'll have 62. Or I could add this 2 millimeter spacer I have. Why don't I just hold these things up? I could swap with this one, or I could add 2 millimeters with this one. So I could do 58, I could do 60, I could do 62. I could play around with it a little bit and see which one's absolutely best. But I think they're pretty round now. This is pretty much what I have now. So good enough. At some point, you got to say it's good enough. And I think we're probably there. Whoops, sorry. It jumped ahead. Yeah, sorry about that. So I did my first real sky trial on the 12th of January. These are 3-minute subs. So took 3-minute long pictures with my telescope. It is a 10-inch telescope on a Sandy G11 mount. And I did a number of pictures in red and green and blue, 3 minutes apiece. So it's a total of about 1.5 hours in total exposure. And I did some playing around with the processing. Those of you who've been to the AP-SIG know that this summer I was playing around with some of the more interesting PixInsight packages, trying things out. So I did try this a couple different times with things that I've been tinkering with. And this is the one I decided I like the best. Still needs a little work. I will, take more pictures when we get a little bit of better night. This wasn't the clearest night, wasn't the best setup at the time because, there were some clouds in the sky. I think there was a bit of a moon up. So, we'll try it again later and I'll perfect it even further. But I think it was pretty good for a first attempt. The other thing that I worked on is getting a Canon adapter. So with my old S-Big that I have here, I have this adapter right here, which you can put on instead of the nose piece that allows you to put a Canon lens on it. And I experimented with that a number of times. I thought it was really fun and interesting. It allowed me to take a picture like this one right here. That was pretty cool because it allowed me to see some things that you don't normally pick up. Like, for example, see this big red blob here? It was very difficult to find out what that red blob was. If you don't know, this picture is hydrogen alpha picture of the Milky Way galaxy. And that red blob is a gigantic dispersed nebula. Do I remember what it is right now? No, I've forgotten again. We could look it up again, but it was very hard to find because it's not something people usually pick up because it's a gigantic and dispersed blob that you only pick up with the widest exposures. Has a very low surface brightness. So I managed to do that with a Canon lens, and I hope to do more of these experiments sometime in the future.
From your front yard?
No, this was Cheslin. Cheslin Nature Preserve. That's where I did that picture.
What's the F ratio that you're working
For this one,
Yeah.
it was a really wide lens. I think it was 14 millimeter lens.
But what's the F ratio?
I don't know for sure. It was a long time ago. Whatever I set the dial to, because on a Canon lens, you can select any of the F ratios. I'd have to look it up if I recorded it somewhere. You do want to stop those lenses down a couple of stops
Why I asked.
because when they're wide open, they do mess up the stars a bit.
Yeah.
But do I remember which one it was on? No, not really. I do remember which lens I used. It was the Rokinon 14 millimeter for that one. I also have the Rokinon 85 millimeter right here, which I do like to use for astrophotography.
About how long is that exposure?
I don't remember without looking it up,
Okay.
but it's on my computer.
Like minutes, I'm guessing?
Oh, it's
Seconds?
definitely,
Oh,
yeah,
okay.
it's like, it's a stack of many exposures.
Okay.
So we're talking maybe an hour or something,
Okay.
but I can look it up.
Oh, yeah.
Yep. But the main point wasn't to talk about that. The key point is I want to do things like that. I want to experiment like this in the future, because that was something I was just kind of starting to play with my S-Big and hadn't got very far. Thing is, when I wanted to take this off and mount something for my Canon lenses on here, they don't make one for the 36 millimeter filter wheel. So I was like, okay, how do I get this on here? And so I did some hunting and looking online. I figured out the space that I would need, like how thick of an adapter would I need in order to make this work. And then I'm like, well, on the one hand, on the one end, there's T-threads, and on the other end, we need Canon. So I just started looking for something that was approximately 10 millimeters, maybe 12 millimeters, maybe 11 millimeters, trying to find something about that thick that would work. I eventually found one, which should be in here too. I managed to find this after a whole bunch of searching on the internet. It ended up being a QHY Canon EF EOS lens adapter with an M42 male thread on one side. So this adapter will allow me to put Canon lenses on my new camera. And I actually tried it. I set it out on a table and just kind of pointed the camera up at the sky with the lens attached. And I immediately saw a live view of the Orion Nebula. And I could just turn it. It was like video. And I was like, that's awesome. That would be fun to play with. And that would be kind of cool at an outreach. You could just point it up at the sky and say, so there's what you see right there. And you actually see Orion on the computer screen with the nebula nice and bright. And it was like, you had super eyes, this is what you would see. So I thought that was cool. I'm going to play with that more. That's a useful little adapter. Anyone who buys one of these cameras should look into that. So that's cool. Stay tuned on that. I'll keep working on that. And thus,
Rick
Yep,
mentioned,
yep.
if you ever need an adapter like that, and you can't find one that's a perfect match, and you know the distance.
Yep.
You can go to Precise Parts and figure out whether they can make one or not.
Oh, then they
And
make it
can
for
make a custom adapter for you, that's exactly right.
oh, that's cool. Nice.
Not cheap, but right.
Yeah.
It's an alternative, sure. And that leads me to my next point. So I will have this for sale fairly soon because I've now transferred all of my filters to my new camera. And so now I won't need this one. So I'm thinking about $700 would be reasonable, but I'm not 100% sure of that price yet. I'm still thinking about that. Here's some examples of some photos I've taken with it in the past.
The photos come with it, right?
Well, I mean, yeah, I can
right.
send the photos.
Yeah.
If you like the photos. Sure. There aren't any filters that come with it. It does have an 8-position filter wheel and it was working perfectly. Taking great pictures just before I switched it over. So, yeah, could be available soon. If anyone's interested, just send me an email. We can check that out. Anyone have any questions about the new camera or that thing?
What year did that come out?
Think about 3 years ago. 2
Okay.
years ago, something like
So
that.
you bought it new though, right?
Yeah, I bought it new. Yeah.
So what basically is what you got there in the way of
Oh,
the narrative?
I can't tell you
It
that.
was a Christmas gift. You paid nothing.
I can't tell you, Christmas present.
So any problems with counterweighting your telescope?
No. Yeah, because I have the same counterweights I had before. You just move them sideways.
Okay.
Yeah.
The new camera looked lighter than the old.
Yeah, they're probably about the same.
Yeah.
But that's a good question. I think they're about the same. All right, that's it.
Thanks, Rob.
Anyone has further questions or wants to see? Huh?
What is that picture of the Ada Karina that you were looking at last week?
No, I didn't see it. It was too low. It was like 2 degrees above the horizon.
It was in Florida last week.
Yeah, it was 2 degrees above the horizon.
All right, next up, Ava is gonna share a trip that she took out to Arizona. All yours. You wanna run the helm or? Okay, I can do it for you if you just wanna talk. Okay, cool. Can someone? Let's see if I can duck. There we go. Yeah.
Good.
Yeah, all right, you can press it. All right, over the break for me, I went to northern Arizona. It's right near Flagstaff. It was basically like camping, sort of. I think it was, my mom did it as like glamping, so fancy camping. But we stopped by Sedona on our way there. It was pretty cool. We only went there for like 3 days, but the place we went was very secluded. I mean, you can see the mountain photos, all that, you know, it's just away from everything. So the reason for the trip was specifically for the dark skies. You can go to the next slide.
These are all photos you took?
Yeah, my mom and I both.
Cool.
took those. But yeah, I got a sea star for Christmas, so I got to finally try it out
Great.
while I was out there. We also visited Lowell Observatory, which was pretty cool. I really enjoyed that. Yeah, it was pretty good. I liked it. It was freezing cold. It was awful. It was like 10 degrees. It felt like 3 degrees out.
Oh,
Yeah.
what are the little green guys?
I don't know. I think they're supposed to be like little
Aliens?
Yeah, and next to the Perseverance.
Right.
They're the Martians. They're
Oh,
trying to
yeah.
find.
Yeah.
When you were at Lowell, did you go to the outdoor amphitheater observatory thing where you got the heated seats?
No,
No, you didn't go to that?
no, I didn't go.
Okay.
But we did walk around.
Yeah.
and everything.
Yeah.
We saw the telescope that not discovered Pluto, but you know, first observed it, which is nice.
Cool.
Wood
Good.
frame dome, that's.
Yes.
Yeah, I'm pretty sure the history behind it was the dome was built by like a bicyclist guy, like people that own a bicycle shop. They built it.
Really?
Yeah. Pretty cool.
Did you take all those pictures, the S50?
Yeah.
Or something? What was your exposure time on those, you remember?
10 seconds. Yeah, 10 seconds for each one.
How long did it take?
It ranged because it was so cold out. I didn't want to stay out too long, so I think the times range from like a few minutes to like, I think the like middle bottom one, that's the Hidden Galaxy. That was the longest one. That was like an hour exposure.
Mm.
That I'd give up.
Did you use the normal mount that it came with? Or did you
Yeah.
set up an equatorial?
My mom did get an equatorial, but I didn't want to mess with that. I was too scared.
It's actually quite easy.
Yeah. Well, the first night that I tried setting up the Sea Star, it wouldn't work. It wouldn't align properly. I spent like 3 hours in the freezing cold trying to get it to work. So
Never good.
You figured it out.
I kept doing the same thing over and over, and eventually it worked.
Despite what they say is the definition of insanity.
I know sisters tried that.
Right.
It didn't work.
Cool. Yeah, good trip.
Yeah, it's good. I liked it.
Weather cooperated?
It It was cold.
Well,
but
yeah,
Other than that.
the skies, I should say,
Yeah,
yeah.
it was perfectly clear all the nights.
Yeah.
Wow. Very good visibility.
Sorry.
What?
The Crab Nebula, is that
Yes.
one? Sorry.
Yeah.
Awesome.
Yeah.
Cool. Thanks for sharing. All right. Last up, Bill Hannigan is going to share some photos. Let's get you set up here. I can never find a good spot for this window, so I did it just. Where is it? Oh, there it is. Bill, all yours.
Okay, so I'm going to show you some deep sky photos that I was not able to show you back at the Astrophoto Showcase in June. Yeah. So, and tell you a little bit about how I produced them. So all of my data is acquired at the Spencer Observatory west of Fair Hill, Maryland. So fairly significant light pollution there, Portal 5. The observatory was built about 6 years ago. I computerized the roof about 4 years ago so that we could do remote unattended operation. The optics and camera angle have to be set up manually for a new set of targets, but after that, a new run on subsequent nights can be started up remotely.
What do you mean by that, Bill?
What do I mean by that?
Yeah.
I mean, I can stay at home.
No, but the optics manually. You can't.
Okay.
The mount doesn't. I mean, the
Well,
mount.
see, there are multiple optical configurations. And I'll show you the telescopes in a couple of minutes.
Oh.
Okay, so there's a telescope, a reducer that can go on that telescope, and another telescope that can be used.
I get what you're saying.
Changing the optics and also changing the camera angle as the rotation. It's a rectangular camera, and for a lot of objects, it's desirable to rotate the camera to get a good framing. Yeah.
Gotcha. Thank you for clarifying.
Yeah. Okay. So here's the main telescope. It's a 10-inch Cassegrain with a built-in corrector. Let's see. And the native focal length is 1250 millimeters. With a reducer, it's down to 889 millimeters. And it is driven on an Astrophysics 1100 equatorial mount. So the focal ratio in the native configuration effectively is 6.11. That takes into account the obstruction, and for the reducer, it's 4.6. Field of view is there, 0.8 by 0.6 or 1.16 by 0.9 or so. I guess that's blocking part of the view. Let's see if we can we make this go away?
I think there's a.
Yeah, click more on the right.
Yeah.
Okay.
And then it'll say like hide floating meeting controls.
Hi.
Second from the bottom.
Okay.
Up one.
There we go. Floating media control. There we go. Okay. All right. So twice the area of the sky with the reducer compared to the native focal length. That seems to have, okay, there we go. Okay. And so the other option is a piggyback mounted refractor with a wider field of view, shorter focal length, 450 millimeters f 5.3, 2¼ by 1.7 degrees. That's 7.6 times the area on the sky that you can capture with that compared to the native focal length for the Cassegrain. Okay, in terms of cameras, I'm still using the same sensor that Rob is now trying to sell. It's the CAP 8300, so it's comparatively noisy. At some point in the future, we may update to a CMOS sensor with a little bit more area. Okay, it's cooled and temperature control, which you really want for deep sky imaging. It has a built-in filter wheel. Here's the camera. The filter wheel's in the black section here. The main sensor is in the blue area along with the electronics. There's an off-axis guider built into this, and then a 1¼ inch barrel guide camera is attached for guiding. Okay, this is all controlled by a desktop computer that I built. You don't have to build your own desktop, but you can go out and just buy any computer and people do that, works fine. Running Windows with the ASCOM platform for the drivers that are actually developed by manufacturers for their own equipment. And APCC Pro is the software that supports the mount. Sequence Generator Pro is the overall software for acquiring image data and controlling the camera and the focuser, as well as telling the mount where to go. And then lastly, PHD2 is used for guiding and dithering. Okay. A few key points regarding the equipment. Guiding is typically required if you want the sharpest images, unless you're using a very wide angle lens, or you've got a super expensive telescope mount that's way more expensive than this astrophysics. Exposures of a minute or more are needed, usually to maximize the signal to noise ratio. Several hours of total exposure time is a powerful lever against light pollution. And you'll see for many of the images I'm going to show you a fairly high count in terms of the number of hours. Okay, acquiring more data basically lets you produce better images in multiple ways. Okay, and in order to do that, using a computer is essential because you really don't want to be right there at the telescope the entire time it's acquiring data. You'd rather have it acquire data till dawn while you are asleep and having a wonderful night. Monochrome cameras work a little better than one-shot color cameras. For those of you who are thinking about buying a camera, I'd recommend you go that route. And that's it. So let's look at some images. I'll start off with NGC 7822. There's some information here I won't go over. Normally, I'll just mention the number of hours, but also the mapping. In this case, this is a narrowband image with SHO mapping, which means sulfur the sulfur data goes into the red channel, hydrogen data goes into the green channel, oxygen goes into the blue channel. And it's pretty easy to remember the sequence. It just matches R, G, and B. So this is NGC 7822. I like to think of it as the V nebula. Can we turn the lights down?
Yeah, pump this up.
Okay.
You can use a slider, yeah.
Yeah. Okay, well, maybe, yeah, okay. Maybe we can turn those off and turn this one up a little.
Yeah, that might be the trick.
Yeah, how's that? Everybody good with that? All right. Okay, and one thing, if you're interested in learning more about how the photos were produced, all of these have appeared in the Focus at some point or other, and the particular issue of the Focus that they are in is typically opposite the copyright notice. So for example, here we've got January 2024 Focus. All right, so this is a fairly typical emission nebula. We're seeing emission from oxygen strong in the central area. We know somewhere in here there's a very powerful star that's exciting the different gases, the oxygen, the sulfur, and the hydrogen. And it's powerful enough in this case that it's also eroding dust around the periphery and producing these dust structures. And basically where the dust is densest, it holds up against that erosive force. And then as you get farther away from it, it doesn't. And that's why you get essentially a column like this. Well, those columns point back toward the star that's actually driving the nebula and causing the erosion. So when you look at this, you might think, hey, that's the brightest star, maybe that's the one. But if you look at the dust columns, it's clearly not the star that's driving their formation. They're all pointed up in this area. And in fact, it's a star that's hidden by a lot of dust up in this area that's driving the formation of the nebula and exciting the gases here. Okay. Next we have Thoris Helmet. 4.6 hours total exposure time. This can be taken as a wide field image because there is nebulosity that extends pretty far from the center. But what's really interesting is what's going on here in the middle. There's a bubble type nebula here with a lot of different components to it, a lot of individual sections that were produced at different times, presumably. why do they, or how is this Thor's helmet? Well, it looks a bit like a helmet. It's pointing like a helmet. It's got branches coming off of it that reminiscent of horns, like a Viking helmet. So they call it Thor's helmet. Okay. Next, I have the Pelican Nebula. This is a 2-panel mosaic. Okay. And for this, the powering star is well out of the field of view down here and to the left somewhere. Okay. It's a little bit different from most nebula in that there's a lot of dust in the area of the O3. And many, if we backed up to the NGC 7822 and you looked at the area where the O3 is, you'd say that's relatively clear, maybe not perfectly clear. But here we've got the O3 emission and a lot of dust to go with it. How is this a pelican? Well, you've got the beak coming down this way, an eye socket there, his head's up here, the neck is coming down this way. And I might say that's a one wing, that's another wing, this is the body. Okay. And as with everything that anybody says they see in the night sky, you've got to use a lot of imagination. It's not too bad on this one.
Well, you missed the comment back here that you need a few drinks.
You need a few what?
Drinks.
Yeah, you need a few drinks. That's right. Okay. Zooming in on the area around the neck, there's an interesting feature right here known as a Herbig Haro object. Basically, ionized gas jet coming out of a protostar. In this case, it looks like there are actually two of them. One's streaming upward and one downward. And we'll see more of those in a bit. Okay. Yeah, unfortunately, they co-opted the escape key for this thing, so that's going to be in the way again. Well, I guess we'll live with that. Okay, now let's see if the. All right. Okay, next is the Monkey Head Nebula. Okay, I kind of overshot. This is a little harder for some people to see. So I'll start off. How is this a monkey's head? Well, you've got his eye socket right here, where this is in profile.
No, that's up top is his snout. That's his up,
No.
up.
I don't believe it. Eye socket,
Oh, I
teeth.
see it. Yeah. Up. This is his mouth. This is his snout. This is the top of his head. Goes like that. That's how it's.
Okay.
That's how it's.
He's facing to the left.
Well, the way I look at it, this is his eye socket. These are his teeth. His hair is coming along down this way. He's got a bit of a rosy cheek. But again, a little bit of imagination. Sometimes my wife looked at that and she said, I don't see a monkey's head for anything. So, you know. Okay. Zooming in on this, there's something a little bit unusual down here. Sulfur emission normally shows up at the edge where the solar wind and the UV from the powering star that's driving the formation of the structures in the nebula is meeting up with the dust and the gas, the denser material. But in this case, there's a very strong sulfur emission here is sort of not. And that's a bit unusual. I don't know why that is, but I thought it noteworthy. Next is the Lion Nebula. Again, this is, and as we go along, these things are probably going to look less and less like what they're named. Okay, certainly the lion's not that great, but two front legs, a back leg. Okay. Let me start this one more time here. Really, seriously, there's no way to get this.
Yeah, hide it again, Bill.
All right.
You got it.
Well, it's sort of disappeared. Okay. Come on. There we go. Okay. So now let me back up there. Stout front legs, one rear leg, a bit of a tail. So not very much to hint at this being a lion, and certainly not a lot of head.
I don't think you have so much detail, like
that's
during what you would see in it. That looks like a triceratops.
Usually, usually when people, a wider field of view usually makes this look a little better. as a lion, but no, it's not a great lion. Okay, there is an unusual area of O3 emission back here. Normally, O3 is right in the middle of the brightest part of the nebula, and then that's all you see of it. But in this case, this is well off away from the bright part of the nebula, which is a little unusual. And it reminds me of a big O3 arc they've discovered recently near the Andromeda Galaxy. I can't show you that. I don't have a picture of that one, but it's interesting anyway. Okay. Next, Leo triplet.
Yep.
Maybe we can move this guy.
Do the more, Bill.
Do the
Yeah.
more.
Oh.
Okay.
Do the more and
Yeah.
High floating.
And high floating. Okay, and I just can't use escape anymore.
That's
All right. Okay, so no zooming in. So we got the Hamburger Galaxy on the left, M65 here, M66 there. You can see a white stream of tidal stars. Don't know which direction they're going, either toward the Hamburger or away from it. Okay.
That's the topics falling off.
There we go. Okay, a few other galaxies in the area, but not really very much. Zooming in on the Hamburger, you can kind of see where the name comes from. So it's red in the middle, like a piece of beef, and kind of puffy white on the top and the bottom. Okay, being the bun. Okay. Unless you're really hungry, I'm not sure you would think of that as a hamburger right off. But anyway,
Roughly, when were these objects named? I guess.
well, you know, a lot of these things were named back in the visual days. So
But they didn't have hamburgers back then.
Yeah.
they had
Oh.
no,
Good question.
I'm talking pre, 90, 95, before astrophotography really became a major deal. I mean, sure, there've been photography and astronomy going back to the late 1800s, but I think most of these were named by visual astronomers. Okay, M65, not too much to say about it. Maybe there's a little bit of a what do they call it? Bar across the middle, a bar across the middle, but other than that, not a lot. M66 is pretty unusual. It seems very deformed to me. Like this side has been kind of crushed in. We've got a somewhat elongated central section, pretty large area that's got young blue stars in it and streaming off in this direction. And of course, we also have some tidal stars being pulled away. So probably a lot of gravitational interaction on this one.
You think there could have been a galaxy collision in the past?
There's a possibility. The argument is that these three galaxies are actually gravitationally interacting with each other significantly, but there are oftentimes is a dwarf galaxy somewhere that you wouldn't think has any impact on anything, and that's the explanation. So it's better not to be too definitive about what is causing, unless you've found information on it. Okay, next up is the Ring Nebula, and this is at the longest focal length, and as you can see, the Ring Nebula is pretty tiny. But it's bright, it's mighty. Zooming in on it, you can see some detail there, and if you check this against Hubble, there's evidence that all of the detail here is real. Okay, if you stretch the image a bit more, which totally saturates the bright Ring Nebula, you can start to see some of the other things in the vicinity. There's IC 1296, a companion galaxy, and a smattering of other things, but mostly stars. There's that companion galaxy with a tail, and surrounding the Ring Nebula itself, there's another very faint series, another essentially outer ring to the Ring Nebula. I'll have to come back at some point with more exposure time and probably other equipment in order to try to pull that out. Okay, next I have M106. This is a Seyfert galaxy, which means it's got an enormous black hole in the middle of it. And the accretion disk of that is not parallel to the plane of the galaxy. That reportedly produces some interesting effects. So let's have a look. Sirius M106, zooming in a little bit, you can see, first of all, there's kind of a bright disk to the center and then a dimmer outer disk to it, where a lot of galaxies will start off bright and just gradually fade down to something dimmer, or when they get a significant structure, you'll see the structure to it. But so this is a little different in that regard. I'm going to switch over to the hydrogen enhanced RGB version here, and you can see a gas jet streaming out at some angle relative to the plane of the galaxy. And this is supposed to be the result of the black hole and the chaos associated with the accretion disk. Okay. This is the Coma cluster of galaxies. And there's no one galaxy in here that's particularly spectacular. These, of course, are very large. The Coma A and Coma B are just enormous galaxies, but they're elliptical galaxies, so not a lot of detail to look at. The thing that's interesting here is the sheer number of galaxies that are present. So this is a little bit like the amateur astrophotographers' Hubble Deep Field. Taking pictures here can pull out quite a number of galaxies. We've got maybe 50 or so IC and NGC galaxies with red ID tags here, and then over 100 the principal galaxy catalog entries with green tags. If we zoom in, which is going to cause some trouble, but I still want to do it, and look around, you can see there actually are quite a number of other galaxies here, like this one and that one, all around that don't have any identification. So there's even more galaxies than what the IDs would tell you.
You could name them.
I could name them, yeah. So now, okay.
What if you just hit page down from there, Bill?
Page down from
Yeah.
here?
Is that,
Page.
make sure you, yeah.
Okay, page down seemed to work to shrink it. Okay, that's good. Let me see. Okay. All right, next up, I have the Andromeda Galaxy. The luminance here was a 3-minute exposure because anything longer would saturate. Otherwise, 5 minutes for RGB and 10 minutes for narrowband H alpha in this case. Okay, overshot. So here's the Andromeda Galaxy. And of course, the main historical note about this is that a little over 100 years ago, this was known as the Great Nebula in Andromeda. And a number of people still figured that this was basically a big cloud of swirling dust within the Milky Way. And I remember until a couple or 3 years ago, there was a picture outside here that a black and white picture of M31 that had that title under it, the Great Nebula in Andromeda. A nice little piece of history. Hopefully that's still somewhere. And the very first of the Cepheid variables that Hubble found is pointed to here. I'm going to zoom in on that in a minute to show you that. But since Hubble found that one, a number of other people, of course, have been looking and found a fairly large number of type 1 and type 2 Cepheid variables. Okay, so we're going to zoom in on this little section here. And that is the first of the Cepheid variables that were started the ball rolling as far as evidence that this, in fact, was a separate galaxy rather than part of the Milky Way.
So you can actually image that with your, what was this image, please? The 10-inch?
A 10-inch, yeah.
I assume you needed a bigger telescope just to resolve a star like that. That's amazing.
It's 23 hours of
Yeah.
exposure.
Yes, so.
Well, you know, the exposure time is there to boost the signal of noise so you can see all of the other details here. That star probably wouldn't require 23 hours.
Still, you can see it.
Yeah,
Amazing.
but you can see it. So on the lower left side of the galaxy, there's an object called NGC 206, which is an OB star association. So that's very powerful stars, type O and type B. And interestingly, within there are some stars that range in magnitude from minus 3.6 to minus 6.4. So if you remember, I think Sirius, the brightest star in our sky, is what, 1.4 absolute magnitude? Okay. And there's a Milky Way star here that, of course, looks brighter because it's so much closer, but its absolute magnitude is only 3.51. So these are very bright stars in there, even though they don't look that bright in a photograph because of the great distance. Okay. Couple other things that are interesting to me anyway is there's a fairly uniform distribution of hydrogen emission nebula throughout. And if we, I think we can safely zoom in at this point. And scan around. A little bit more of a concentration here, but it's just seems unusual that it's so thoroughly and so evenly distributed, that activity.
Page down.
That. Page down, got it. Okay. Now we have to fix this one more time. Okay. All right. So next up, M101 with a supernova. How much of M101 you get to see depends on which way you stretch it. Okay. In this case, if we stretch this a little harder, we could show a lot more of the fainter areas of M101, and we would lose detail in the very bright areas. Okay, I've actually backed off on the stretch somewhat so I could increase the contrast. And we'll zoom in a bit. You can see there's some truly fine structure within this, and that's, of course, part of why they call this a grand design galaxy. One of the interesting things about M101 is this spiral arm here is pulled out so far out of whack relative to the rest of the galaxy. The explanation I read is that this dwarf galaxy here has been doing that. You know, it's a gravitational interaction thing. That seems like a pretty big job for such a tiny little galaxy, but who knows how much mass is actually there.
Dark matter.
Yeah. Okay. And by the way, this is that supernova I mentioned. With a much lower stretch, you can see that the supernova is quite a bit brighter than even the core of the galaxy. And that in actual measurements, the red, green, and blue signal at the center of that supernova is more than 30 times brighter than the core of the galaxy. This was about a week after that supernova was discovered.
Do they have any idea what the solar mass was for that star?
You know, I'm pretty sure somebody has that, but I don't remember what that is. Sorry. Next up is the Phantom Tiara Nebula.
So phantom, you can't see.
So where is the Phantom Tiara? You know, this is who knows? I don't know. But it's kind of a fun object. I should say at the outset, on LRGB images, I always do a spectrophotometric color calibration, which basically calibrates the color in the image according to multiple reference stars within the image. In this case, that ended up with this reflection nebula in the center being white, and I really aesthetically did not appreciate that. So I used a mask in order to change the color of that reflection nebula more toward the typical blue, because I like the way it looked. Okay. But other than that, the color everywhere else is going to be pretty accurate. So what is this? Well, this is part of the Perseus molecular cloud. And if there had been an O star or a really strong type B star here, a really strong blue star, you might see a big emission nebula here because there's plenty of hydrogen around. But there's not. And because there is not, we can actually pick up a number of very tiny little nebulas. They're Herbig-Haro objects, basically more of that, those ionized gas streams that are screaming through space and exciting hydrogen in particular as they go along. These apparently move rapidly enough that they can show proper motion in a few years, which is really kind of freaky when you think about it. Never thought of an emission nebula moving, but there you go. Next up is the Cocoon Nebula. And the thing that this is LRGB. Some emission nebula have hydrogen, but they really don't have a significant oxygen or sulfur component to them. And this one being the Cocoon and some dust around it, I did photograph this in LRGB to try to really show that dust. To me, they should have probably called this the Cocooned Nebula because the nebula is cocooned inside a big pile of dust. I forget what the LDN number is for that, but this dust actually picks up again off to the right, and there's another big section of it. But there we go. Almost to the end here. This is the Heart of the Heart Nebula. I did this in two different mappings, RGB and in a dynamic SHO. So SHO is, of course, the usual, but in dynamic SHO, typically hydrogen is added back into one of the channels in an amount that's variable depending on the strength of the oxygen emission. So in this case, hydrogen is added into the red channel along with sulfur, but to an extent that depends on the oxygen, the strength of the oxygen emission. So when oxygen is strong in the image, essentially no hydrogen gets added. But when there's hardly any oxygen, then the emission, then the hydrogen gets added in and boosts the red channel. Okay, and that's done so that in the SHO image, which you'll see in a minute, you get more of a color contrast between the features. So here's the RGB version, and it's been deconvoluted which helps to trim back the brightness of the stars. The stars are still really overpowering. There actually is more to the nebula than you can see here. If I stretched it so that you could see it, the stars would be even more bloated and more overpowering. Okay, still, it's an image I like. It's nice by itself, but this next one also has some advantages. So this is the dynamic SHO version of the image. Now you can see more of what's going on in the nebula here and through the center, and the hint of oxygen emission that's all through the basin, if you will. And especially, you can see better detail, more of what's going on in the dust areas down here at the bottom. Okay. So just scan around here. Nice. Okay. So page down. Okay. Got to remember that. Nice try. Okay.
Good call there.
Pardon?
Good call, yeah.
Okay. And last, I'll show you the Angel Nebula. This is pretty unusual and a very, very faint object. A 5-minute exposure, this barely shows anything. It takes a lot of exposure time to really pull this out. You have a bit of emission nebula here in the red. That's hydrogen, obviously, but the rest of it is a combination, is mostly reflection nebulosity. Although these reflection nebula have a little pink streaming through them, which is pretty odd for reflection nebula. So a little bit of hydrogen emission probably in those pink areas, those pink stripes. And there is this orange area is a bit unusual as well. It's not like hydrogen alpha is orange. It's not. Okay, so maybe a mix of hydrogen alpha and some, or just a plain old broadband orange color coming out of that. there is one of the brightest infrared sources in the night sky is supposed to be behind this, and that dust is said to be, or reportedly, thick enough to block like or knock down 30 magnitudes off of any star that's in there. So that's a pretty dense pile of dust in there. How is it an angel? Well, this is another case of and might as well, you could say maybe pixie, maybe fairy, but for an angel, one explanation is that these are the wings of the angel. And I would say maybe this is kind of a gown flowing down from, but the rest of it, it's a case of whatever you want to imagine.
Or it's just like a biblically accurate.
It's what?
Biblically accurate.
Not biblically accurate, no.
Bill,
Yes, sir.
there's a lot of green around the edges and there's.
Yeah,
Is that an
This,
artifact or
yeah,
something?
that is absolutely an artifact, and I would dearly love to get rid of that. I can tell you where that comes from. This is very near the celestial equator, and there are just an enormous number of geosynchronous satellites up there that are constantly tearing through that area. Normally, with multiple exposures, you pixel reduction or pixel rejection will see that, these pixels are unusually high and this particular frame, reject them. But there are so many of those satellites moving through this particular area that the pixel rejection can't get rid of. There are some heroic image processing steps you can take to go back and edit each one of those images and knock out the satellites. Might do that at some
We'll
point.
have that for us.
Pardon?
Next time you'll have that for us.
Maybe.
I mean, you have the data,
Pardon?
have the data.
I have the data. Yep.
Just need the time.
Have fun. Oh, that's what I don't have.
Yeah.
Okay.
Cool.
So that's it. Any questions?
When you do these monumental 20, 30-hour projects,
Right.
I mean,
The
are you-
key is I'm not there the whole 20 or
right,
30
right, but are
hours.
you doing them like not, as close together? Or is it you'll do a little bit and then 3 months later you'll do a little more?
Typically, I set up the instrument for a particular object and find 2 or 3 other objects that will work well at the same framing and the same focal length. So then the first one goes over, you image that for a while, the next one comes up, you image that for a while, and maybe the third one. It's not unusual to actually acquire data for 3 different objects on the same night.
Mm-hmm.
And then do the same 3 objects again on the next night.
Right.
And so on until the first object finally gets too far and it's not worth imaging anymore. It graduates and you add something else to the list. So the main thing is keep acquiring data for the entire, night so that you're getting the maximum amount of data.
Cool.
Okay.
So how much you got in?
Well, some of this equipment is mine and most of it's Rick Spencer's. The observatory, the telescope is Rick Spencer's. That telescope was used when he bought it, I think about 10 grand for that. And then, the mount was probably a little bit less than that at the time. It's been a while. The observatory, yeah, it costs some money to build an observatory like that.
50K?
No. That was probably,
No, for the whole thing.
Oh,
I don't think it gets that high. I think that the observatory was maybe around 12 to 15 total by the time you had the concrete and the guys who came out and built the structure.
So you're looking at 35K, right?
It's probably 35K worth of stuff. Yeah. So it's not trivial, but it produces some results.
yeah, it's cool.
But you were using the same sensor as I am. So everybody saw the pictures.
Yeah, you couldn't get photos.
I don't want to use one person.
Cool.
Yes, sir.
On your first couple of photographs, you say that one or two of the stars in particular were calls the nebula or whatever. How do you know that?
Oh, well, you have to do a little bit of research on it.
I mean, how did they come to
How-
that conclusion?
Usually it's whatever the they find the star that's powerful enough to do it. There was a lot of question about the star that powers the North American Nebula and the Pelican Nebula, and that went on for a long time. And they were looking around. They said, I think at one point there was a suggestion that it was Deneb, and the analysis of it said Deneb's just not powerful enough to do that. And then they discovered that hidden in one of the dusty areas of the nebula was this type O star that was just a monster. And they did the calculations, and it comes out, yeah, that's the only one. And so they assigned it.
Basically, it's spectroscopy they're using.
That's right. It's mostly spectroscopy that's used to determine what type stars are, even though their brightness is diminished. So you can't look at them and say that's bright, so that's the one.
How much time do you have to spend processing these images? I see you have 30, 40, 50 hours.
Yeah, each one of those images, 6 to 8 hours probably. Okay. I mean, yeah, it's got, sometimes some of them go much faster and others go slower.
Sometimes you do them multiple times. You're like, I don't like how that came out. Let me do that again.
Yeah.
Oh, I know I could tweak that. You gotta do it again.
Cool.
Yeah.
Well, thanks, Bill. Thanks to all of our speakers tonight. Really cool. Appreciate everyone's contributions. And there are refreshments, so please join us in the library.
Oh, thank you very much, Jeff. I'm going to go outside and read it.
Yeah.
Sure.
Aurora out there would be better. Bye-bye, everybody.